Okay, so let's try to compute a partial derivative. Find partial derivatives of f equals x squared sine y plus x. So first thing to note, I have x squared times sine y. If I'm holding y constant or holding x constant, these are not things that I'll use the product rule on, right? X squared times sine y. At one point, this will be some constant times x squared or some constant times sine of y. Let's compute this though. So fx is going to be, again, partial with respect to x of x squared sine y plus x. This is the derivative of this function f with respect to x if I consider y as a constant. So this will be 2x times the constant sine y plus 1. Similarly, fy is going to be the partial with respect to y of this function of x squared sine y plus x. And I'm treating x squared as a constant. This is a constant for the time being. And so if I treat x squared as a constant and x as a constant, I should get x squared times cosine y, that's the derivative of sine y, plus 0, 0 being the derivative of x if I'm holding it constant, if it's considered a constant. So let's even write plus 0 for emphasis. So actually, maybe let me ask another question here, add on to this question. Let's suppose I want to find the tangent, find a line tangent to this f of xy that's parallel, let's say, to the xz plane. In other words, I want to move in a direction that's strictly in the direction of y. I don't want x to change, and I want to know what is the tangent of this. What is the slope of the tangent? And so I have here f of y, or f sub y. Let's say even, actually, we maybe need to give a point. So find a line tangent to fxy parallel to the xz plane at the point, let's say, 2, 0. So xy equals 2, 0. So fy is what's going to give us, in this case, the slope of this tangent. Fy of 2, 0 is going to be equal to 2 squared times cosine of 0 plus 0, and that's going to be 4. F of 2, 0 is going to give us the point associated to this input, this 2, 0 input. And this is 2, 0, 2, just plugging into my function f. And so here is the slope of that tangent line. So this means this is parallel to 0, 1, 4. Right? If I change in the x's, so a change in y direction, and this is my change in the z direction. And so if I combine all this information together, I'll call this maybe L sub y for y direction. L sub y of t is going to be 2, 0, 2 plus t times 0, 1, 4. Okay, and if you plot this in GeoGebra, this function and this line, and zoom in and spin around, you can see that this is actually tangent and that it goes in a direction parallel to the xz plane.